So, good morning everyone. Today, as per the demand of some of the students, I am going to discuss with you some of the basic things, very basic things of electrical engineering. First one is, what is charge? Charge is a quantity of electricity responsible for electrical phenomena. Please write down. Charge is a quantity of electricity responsible for electrical phenomena. Charge, electron charge is equals to minus 1.602 into 10 to the minus 19 coulomb. Charge on the proton is equals to plus 1.602 into 10 to the minus 19 coulomb. So now come to the next point, that is current. Rate of change of charge is known as current. Write down. Rate of change of charge is known as current. Current is a scalar quantity. Conventional direction is opposite to the direction of electron. Conventional current direction is opposite to the direction of electron. So in mathematical terms we can write I, the function of t, is equals to dq by dt. Q is the function of time and the unit will become coulomb per second. So it equals to dq by dt or I equals to q by t coulomb per second, that is static. I equals to q by t, that is static, and I function of t is equals to dq, q is the function of t by dt coulomb per second, that is dynamic in nature. So qt will become integral minus infinity to t it dt coulomb. So when we integrate that it dt, that will give you the charge. So now you can further expand this formula. Q of t is equals to minus infinity to 0 it dt plus 0 to t it dt. That will be equals to q function of t is equals to q of 0 plus 0 to t it dt. So you can have a numerical on this also to have a better understanding of this concept. Suppose a numerical is the current flowing through capacitor as shown in the figure. Find the charge acquired by the capacitor up to 5 microsecond. So qt equals to it into dt. So as the question is saying, we have to find out the charge up to 5 microsecond. So the value will come qt equals to 0 to 5 for dt. That will be equals to 0 to 3 it dt plus 3 to 4 it dt plus 4 to 5 it dt. Now when we integrate these values, the value will be coming 1 by 2 into 3 into 5 plus 3 into 1 plus 1 into 3 plus 1 by 2 into 1 into 1. And when you calculate the values, then it will come 15 microcoulomb. Now we will come to the next topic, that is EMF or voltage or potential. So work done to move a unit positive charge from infinity to reference point is called EMF or voltage or potential. Work done to move a unit positive charge from infinity to reference point is called EMF or voltage or potential. So V is equals to the dW by dQ or W by Q, joule per coulomb. V equals to dW by dQ or W by QQ, joule per coulomb. Voltage is a scalar quantity. Electric field intensity is negative potential gradient. Electric field intensity is negative potential gradient. So E is equals to minus nebula V. E in 3D we can write E is equals to minus nebula V. E is the electrical field intensity. E can also be written as V by L, volt per meter. Voltage by length, volt per meter in one dimensional. So now we can discuss a little bit difference between EMF or potential and potential difference. So we can say that, please keep noting, I will be very fast. Please keep noting. So EMF or potential, the first point you can write is cause. EMF or potential is the cause, potential difference is the effect. EMF or potential is the cause, potential difference is the effect. Second point is EMF is independent of rating of resistance and current. It is independent of rating of resistance and current. Potential difference, it depends upon the rating of resistance and current. Third point you can write, EMF or potential, it is source of circuit. It is the source of circuit. Potential difference is the part of the circuit. EMF or potential is measured in volt and potential difference is also measured in volt. So you can have some numerical problems. So now suppose a circuit is given with 6 volt and resistance of 2 ohm and 4 ohm is connected with that. Now EMF equals to 6 volt and I equals to R total R if the two resistance are connected in the series, so the total resistance value will become 4 plus 2, that will be 6 ohm, and voltage EMF equals to 6 volt. So when we calculate the value, then you can easily get the value of all the parameters and you can easily find out the value of voltage and EMF in this. Now suppose a source is there, and when that source is transferring the energy to the load, then some energy losses will be there, some energy storage will be there. So when resistance is connected, then loss of energy will be there, and when some capacitance or inductance will be there, then some storage of energy will be there. So the potential, you can say C, capacitance potential, so the work or energy stored will be equals to half CV square. C is the capacitance and V is the voltage, and in inductance L is equals to W equals to half Li square, that is the kinetic form, and in capacitance that will be in the static form, that is potential. So in class 10th also we had read the very basic rule, that is Ohm's law. The current density in a conductor, the current density in the conductor is proportional to the electric field intensity, keeping the temperature is constant. So Ohm's law, what we know about Ohm's law is current density is in a conductor is proportional to the electric field intensity by keeping the temperature constant. So J is directly proportional to E where temperature is constant. So vector J is equals to sigma vector E. Point form of Ohm's law or differential point form of Ohm's law, this is called point form of Ohm's law or differential form of Ohm's law. J is the current density, ampere per meter square, sigma is the conductivity, 1 by ohm per meter. Reciprocal of resistivity is known as conductivity. So J equals to sigma E. So J, that is current density, that will be equals to I by A, current by area, equals to sigma, that is conductivity, so 1 by rho, 1 by resistivity, and E equals to V by L. So we will get the formula of current, I equals to V into A rho by L, and I equals to rho by L. So we will get the final formula equals to V by R. As we know, R equals to rho L by A. So I equals to V by R. So current flowing through the linear conductor is proportional to the potential difference between two ends of the conductor. Current flowing through the linear conductor is proportional to the potential difference between two ends of the conductor, keeping the temperature constant. So current is directly proportional to the voltage and temperature is constant. So I equals to V by, so R equals to V by I. Please keep this formula in the boundary, and now you can put a value, you can different value and get the result value of R. So now next point is resistance does not depend on voltage or current, but it depends upon the ratio V is to I. Resistance does not depend on the voltage or current, but it depends on the ratio of voltage to current. Current, that will be size, voltage, that is rating. So R is equals to, R is directly proportional to L and inversely proportional to A. So R will be directly proportional to L by A. So R equals to rho L by A. As we know that curved surface area of suppose a cylinder having two circular ends, so curved surface area will be pi r square plus area equals to 2 pi r L. So you can calculate the value of the balanced things. Now some of the limitations of Ohm's law is, it is applicable to linear element and when the temperature will be constant. So it is applicable to linear element and temperature is constant. Reciprocal of resistance is known as conductance. Reciprocal of resistance is known as conductance. Now we will come to next topic, that is power. Rate of change of energy is called power. So P is equals to dW by dt. Now P equals to dW by dq into dq by dt. So power will be equals to V into I, and now I equals to V by R. So it will become V square by R, and V equals to IR, so it will also become P equals to I square R. Now, so final formula, you can just have a boundary on that formula is P equals to Vy, then you can put the value of V equals to IR in that equation, you will get different formula, and I equals to V by R, you can get another formula. So some units we are using most frequently, kilo, that is 10 to the power 3, mega 10 to the power 6, giga 10 to the power 9, milli 10 to the power minus 3, and nano 10 to the power minus 9. So we can majorly say that control of electron is electronics, control of electrons is electronics, and flow of electron is electrical. Control of electrons is electronics and flow of electron is electrical. Now what is energy? Next topic is energy. Write down, please write down. Capacity to do work is known as energy. So P is equals to dW by dt. Now when we integrate the value, then W is integration of P dt. W is integration of P dt, and W is equals to P equals to Vi. So when we keep the value of P Vi dt, now W is equals to V equals to I equals to V by R, so V square by R dt. Now W equals to IR dt, that will be the unit will be in joule. So the final, in the steady state, the W energy will become W is equals to VIT. So you can find out the energy also by, please write one numerical. Suppose that a mobile phone with 12 volt is good for 10 minutes for talk time. Assume during talk time it delivers constant 2 ampere current and voltage drop linearly from 12 volt to 10 volt as shown in this figure. You can see the figure here also. A mobile, suppose I am repeating once again, a mobile phone with 12 volt is good for 10 minutes for talk time. Assume during talk time it delivers constant 2 ampere current and voltage drop linearly from 12 volt to 10 volt as shown in the figure. Find the energy delivered by the battery during talk time. During the talk time of the mobile, what is the energy delivered by the battery? So W is equals to integral Vi dt. Now we will put the I outside this integration value. So I is equals to V dt. Now I is given as 2 ampere. I we have given as 2 ampere. So we will put the value of I2. Now we can integrate the value and get the result. That will be equals to 2 into bigger bracket 10 into 60 into 10 plus 1 by 2 into 10 into 60 into 2, that will be equals to 13.2 kilojoule. Or you can also put the formula 0, 12. You can make the quadrant like mathematically you can go. So 0, 12, that will be 10 into 60, 10. So Vt equals to y2 minus y1 by x2 minus x1. That will be equals to y minus y1 divided by x minus x1. So 10 minus 12 upon 600 minus 0, that will be equals to Vt minus 12 t minus 0. So the Vt will be minus 1 by 300 into t plus 12. Now we can integrate the value as this is the function of time. So W is equals to 0 to 10 into 60, that will be equals to minus 1 by 300 into t plus 12 into 2 into dt. So it will finally come 13.2 kilojoule. Now we will move to next topic, that is inductor. Conductor which has twist number of turn is called inductors. What is inductor? Conductor which has twist number of turn is called inductor. So when the number of turns will be very more, then the magnetic field value will be also more. When the number of turn is less, so the magnetic field will be less. So the flux linkage through this coil, you can say, suppose that this is a coil, so the flux linkage will be n phi. N phi is directly proportional to current intensity, so amount of the current will be directly proportional to the phi, that is the linkage of the flux. So n phi is equals to Li, L is the proportional constant. N phi is equals to Li, L is the proportional constant. So L will be equals to n phi by I, that it will be equals to Weber per meter per ampere, or Henry you can say. So once again I am repeating, conductor which has twist number of turn is called inductor. I is the current flowing through a conductor and a magnetic field will be generated. So weak magnetic field will be generated when the number of turns will be more, strong magnetic field will be generated. So that will be equals to n phi is directly proportional to I. Now n phi equals to Li, L is the proportional constant, and L equals to n phi by I, that will, the unit will be Weber per ampere or Henry. So inductor does not depend upon the flux linkage. Inductor does not depend on the flux linkage or the current, is known as linear conductor, otherwise non-linear inductor. Inductor does not depend on the flux linkage or current, is known as linear conductor, otherwise non-linear inductor. So you can have a formula, L is directly proportional to n square and L is directly proportional to A. So and L is directly proportional to 1 by L. So in a whole we can write L is directly proportional to n square A by L. So L will be equals to mu n square A by L. So inductance of solenoid is equals to mu n square A by L. L is the inductance of solenoid and mu is the permeability, that will be Henry per meter. Permeability, what is permeability? Ability to allow the magnetic line of forces is called permeability. What is the permeability? Ability to allow the magnetic line of forces is called permeability. So mu equals to mu naught into mu r. Mu naught is absolute permeability, that will be equals to 4 pi into 10 to the minus 10 Henry per meter. Mu is equals to mu naught into mu r. Mu naught equals to absolute permeability, that will be equals to 4 pi into 10 to the minus 7 Henry per meter, and mu r equals to relative permeability, that will be equals to 1 for air, 1600 to 2000 for iron, and no this is having no unit. So now we are going very fast, I know, so please keep noting. Now we will move to second, some of the laws which are involved in these inductors, that is Faraday first law. Whenever conductor cuts rate of change of magnetic flux, whenever conductor cuts rate of change of magnetic flux, an EMF is induced in that conductor. Whenever conductor cuts rate of change of magnetic flux, an EMF will get induced in that conductor, that will be equals to V equals to N d phi by dt. So minus sign will be indicating Lenz's law. So minus sign will indicate Lenz's law. Whenever conductor cuts the rate of change of magnetic flux, an EMF is induced in that conductor, that is called Faraday's first law. Now second law is the induced EMF. The EMF induced in the conductor is proportional to the rate of change of flux linkage. The EMF induced is in a conductor is proportional to the rate of change of flux linkage. So V is directly proportional to d phi by dt. So V is equals to N d phi by dt, equation 1. Now we had read L equals to N phi by I. We can write this equation 2. So phi will be equals to Li by N. phi is equals to Li by N. So V is equals to N d by dt Li by N. Now L is the time invariant, so whenever we will put 1 by N outside, so N will get cancelled and L di by dt will remain. So V as a function of t is equals to L di as a function of t by dt. So V is equals to L di by dt. Now V of t is equals to Lt di by dt plus It dl by dt. L is the time invariant. Here L is the time variant. So It is equals to 1 by L minus infinity to t. That will be Vt dt. So now you can put 1 by L outside. So It will be equals to 1 by L minus infinity to 0 Vt dt plus 1 by L 0 to t Vt dt. Now combining the present and the past, that will become dynamic, and when we consider the present state, that will be static. So the final formula will be I of t is equals to I of 0 plus 1 by L 0 to t Vt dt. So I of t is equals to I of 0 plus 1 by L 0 to t Vt dt. You can have the boundary line on this formula. It will be helpful in the further calculation and numerical solving the numerical problems. Now any element output not only depend on the present and present state, also depends upon the past, is known as dynamic element. So what is dynamic element? Any element output not only depends on the present, also depends on the past, is known as dynamic element. So now we come to the next topic. We will go very fast. Please keep noting. Now power P is a function of time equals to Vt into It. So Pt instantaneous power is equals to L di by dt into It Pt equals to V of t I of t. So P of t is equals to L di of t by dt into It. So the energy stored in an inductor is equals to Wt is equals to minus infinity to t Pt dt. So Wt is equals to minus infinity to t L dit by dt into It dt. So now W of t is equals to L minus infinity to t I of t di of t. So L is equals to minus infinity to t I of t di. Now we will integrate the value and we will get the final result as W of t half L I of t square. So when I minus infinity, that will be equals to 0. So W of t is equals to L half L It into It, that will be equals to half psi t into It. So psi of t is equals to n phi. So now energy stored in an inductor at any instant of time is depend upon the current flowing through the inductor at that instant. So energy stored in an inductor at an instant of time is depend upon the current flowing through the inductor at that instant of time. So W is equals to half B vector dot H vector dV. B is the magnetic field density Weber per meter square and H is the magnetic field intensity ampere per meter. So W is equals to half integral of B vector H vector into dV. So B is equals to magnetic field intensity and H is equals to magnetic field intensity ampere per meter. So energy stored in an inductor in form of magnetic field, that is kinetic energy. Energy stored in an inductor in form of magnetic field, that is kinetic energy. Inductor does not sudden change of current, but it allows sudden change of voltage. Inductor does not allow sudden change of current, but it allows sudden change of voltage for all electrical signals. So based on constant flux theory, inductor does not allow sudden change of current, but it allows sudden change of voltage for all electrical signals. Now whenever DC is given to the inductor, it acts as a short circuit in a steady state. Whenever DC is given to the inductor, it acts as a short circuit in a steady state. So V is equals to L di by dt. So L d of 2 equals to dt, so V will become 0. So the voltage will be 0, then it will be short circuit. So please keep noting. Now at the time of switching, inductor acts as open circuit. At the time of switching, Inductor acts as an open circuit. Now we will come to next topic, and that will be the last topic for today. Capacitance. Two conducting plates separated by some distance in between there is a dielectric material is known as capacitor. Two conducting plates separated by some distance in between there is dielectric material is known as capacitor. So this is the charges. So once again I am repeating, two conducting plates separated by some distance in between there is dielectric material is known as capacitor. So this one is dielectric material, positive charge is here, the positive plate charge, negative charge plate, and distance between this is d, and this is the dielectric material, and V voltage is given. You can note down the figure. Now the charge on plate is proportional to supplied voltage. The charge on plate is proportional to supplied voltage. So Q is directly proportional to V. Now Q is directly proportional to the voltage. So Q is equals to CV. C is the proportional constant. So C is equals to Q by V. That will be, the unit will be coulomb per volt or farad. Now capacitance does not depend on the charge or voltage. Capacitance does not depend on the charge or voltage, is known as linear capacitor, otherwise non-linear. So C is directly proportional to A, that can be considered as equation 1, and C is inversely proportional to distance D and can be considered as equation 2. So now C is directly proportional to the A by D, which will be equals to, C is equals to epsilon A by D. Epsilon will be permittivity and the unit will be farad per meter. So now epsilon is equals to epsilon naught into epsilon R. Epsilon naught is absolute permittivity, that will be equals to 8.854 into 10 power minus 24 farad per meter, and ER is equals to relative permittivity, that is equals to 1 for air or vacuum and no unit. So IT is equals to dQt by dt, dq by dt, IT equals to d by dt C Vt. So now I of t is equals to C dV by dt. So displacement current is equals to C dV by dt. C is the time variant. Now you can derive all the formulas. IT, finally the IT will be equals to Ct dVt by dt or Vt dCt by dt. Now C equals to C naught 1 plus cos omega naught t and V equals to V naught cos omega naught t. So IT equals to C naught into 1 plus cos omega naught t dot d of dt C naught 1 plus cos omega naught t plus V naught cos omega naught t plus d of dt C naught 1 plus cos omega naught t. So C naught plus C naught into 1 plus cos omega naught t into C naught minus omega naught sin omega naught t plus V naught cos omega naught t minus C naught omega naught sin omega naught t. That will be equals to C naught square into 1 plus cos omega naught t minus omega naught into sin omega naught t plus V naught cos omega naught t minus C naught omega naught sin omega naught t. Now I of t equals to C dV by dt, putting the value in equation. So Vt equals to 1 by C minus infinity to 0 into it dt, that plus 1 by C 0 to t it dt. So Vt will be equals to Vc of 0 plus 1 by C 0 to t integral 0 to t it dt. So initial value Vc 0 and this 1 by C is elastance. So you can have the boundary line on this formula, it will help you in solving the further numerical problems. Now I will go very fast. Pt, now power formula, P of t is equals to V2 into it. So P of t Vt, it will be C dV by dt. So energy stored in a capacitor will be W2 t equals to minus infinity to t Pt dt. So energy stored in a capacitor Wt equals to minus infinity to t Pt dt. So minus infinity to t Vt C dV by dt. So dt will be cancelled. So the final formula will be half C V of t square. So minus infinity to t. So V of minus infinity equals to 0. So the final formula will become W of t is equals to half CV of t square. So the